Okay, this is 2009. This will be question 9. We're looking at a thermistor. So it's a temperature-dependent resistor. But we can tell that from this graph. We don't even need to know that. What is the resistance of the thermistor when the temperature is 5 degrees? 5 degrees goes up. Resistance is 5,000. Easy marks, easy marks. Thermistor is incorporated into a circuit to control an air conditioner. Blah, blah. So what's it saying? We want 8 volts across here. Yeah, if it switches on when the voltage reaches 8 volts, it switches off when the voltage is below 8 volts. So on when it's 8 volts or greater, off when it's less than 8 volts. I should have done that originally. 8 volts. Yeah. Okay. The air conditioner needs to come on when the temperature is 25 degrees. What resistance should the variable resistor be? So it's 25 degrees. We need to find a way to use that. So the first thing we do is we go here, we go 25 degrees. Resistance of this is now 500 ohms. Okay? And now we look at this, this is 8 volts, that's 12 volts, so there must be a 4 volt drop across here. Now we know the ratio of these, we can use the voltage divider formula, but I'm going to say voltage equals IR, or voltage is proportional to resistance. Therefore, 8 on our variable resistor equals 4 on our thermistor. Another way of thinking it is, if this is double of that, that's double of this. So we go 8 on 4 equals R on 500. So that's another way, and I like that way. So that becomes 2. Becomes 2, and we bring the 500 over, times 500 equals our resistor. 1000 ohms. Okay, the air conditioner now needs to come on at a lower temperature. Should the variable resistor R be increased or decreased to achieve this? Write increased or decreased in the box. You must explain your answers. Okay. If the air conditioner now needs to come on at a lower temperature, that means we still want this to be 8 volts, but at a lower temperature. So if we go down a lower temperature, we realize the resistance is rising. So we know this thermistor resistance is rising. And so to keep the same proportion, we know 8 on 4 must be this R on this one. So this must be twice of that. This must also be rising. Okay, to keep the same proportions. You can think of it any way you like. So, we go. Temp rising implies, probably have to say more than this, but this is the key essence, implies thermistor. It's rising. Therefore, since ratio of thermistor to variable resistance equals 8 volts to 4 volts, we must increase, if this is increasing and we want to keep the same ratio, then resistance must be increasing. The variable resistor resistance must increase to keep the ratio. The other ways to do it, I'll quickly show you another way because this may confuse you. I may have confused you. But if you're not comfortable with that, what you can do is figure out the current. So current equals voltage on resistance over here. If we increase the resistance, then the current must go down. Okay? So current is decreased. Now we know this resistance over here, so resistance equals the variable, times the current equals the voltage drop. But we want this to stay stable. We want this to stay at 8. So if the current's going down, this resistance must be going up. Okay? But either way, it doesn't matter. You talk about ratios, you can talk about all these things. But if you have a good sense of logic, you get the question right. And we're done with electronics. Fantastic. Have a fantastic day.